Alright, so we're going to take a look at how to sketch the tangent graph. We've already had a look at sines, that's our green graph here, so it started at 0, up to 1, down to pi, so at pi back to 0, 3 pi on 2 at its minimum, and then 2 pi got back, whereas cosine started at 1, at pi on 2 got to 0, at pi got to its minimum of -1, back up to 0 at 3 pi on 2, and then finally getting back to where it started at 2 pi. Tangent will have that same circular function property that it is periodic, that it does repeat, but the graph itself does look very different. So what we're going to do is, again, use the unit circle. So we're going to make that connection with the unit circle to create the graph of tan of x. So we're going to have a look here at using the unit circle here. So again, crossing at 1 on each of the axes and the -1. 0 is the angle made with the positive x-axis, pi on 2 or 90 degrees, 180 or pi, 270 or 3 pi on 2, and then back to 2 pi or 0 degrees again, 360. So what we're going to do is a little animation. I apologize, the degrees are showing up, or the angle's showing up in degrees. That's the only way it'll let me show that. So we'll kind of work on that conversion, bouncing back and forth. So the really important concept is that tan of theta, sorry, I've got the wrong symbol there, is the y value over the x value. So if I'm looking at the coordinates, it's going to be, in this case, 0 over 1. So the point that's plotted is here at 0, 0. Now as that angle changes, the x and y coordinates are going to change, hence the tan value will change accordingly. So let's take a look at what happens when we start going anti-clockwise or counterclockwise. So if I take my angle and I go up to 5 degrees. So my tan value has gone up because in this case the y value has gone up. The x, it's just still rounding to a few decimal places. If I then move to 10 degrees, what we're going to notice is that as these two values change, the ratio will change the tangent value as well. So watching this value as I move this up, so let's go to 15 degrees. Oops, go to 15 degrees, it goes up to 0.27. Now it's going to start to climb quicker and quicker as the x value starts to change more and more rapidly. So the x value is going down. When I divide by a small number, that makes things bigger. So the smaller the number I divide by, the bigger number I'm getting. So here I get to 60 degrees, so sine of 60, cos of 60 is 1/2. So we're getting up to 0.73. We keep climbing and climbing. Now, as the x value, so cos of theta, starts to get smaller and smaller, it starts to grow even quicker. Noticing here, I finally get to 1 over 0. Okay? Now what that's going to do is introduce an asymptote, because when I divide by 0, that will typically create a vertical asymptote. So if we pop on that vertical asymptote there, we can see that the graph is tending towards it. Now thinking again back to the x and y value, as soon as it crosses over, the sign is going to change. So I'm going from up, 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 very, very high and positive, to all of a sudden switching. The ratio is still going to be fairly similar, but it's going to switch to negative. So it's going to jump down here and slowly climb back up towards 0. So let's watch that happen. So here I'm at 90 degrees, going up to 95. I switch quite quickly to the negative side. So I have my point way down here. And as I move over, again, my x value is getting closer to 1 now. So as I keep climbing, here, notice again this would be 45 degrees or pi on 4. So that's when those two are the same, so I get to -1. And then I keep, again this number's getting bigger and bigger, until finally we get back to 180 degrees. Again, the ratio there is going to be 0. So I get at pi radians 180 degrees, I get back to 0. Now when I suddenly switch over to negative, I'm just crossing through 0. I'm not going to have an asymptote there. I keep changing. Again, when I get to the equivalent of 45 or pi on 4, those two are the same, so I get to 1. That's an important value. And then as this number gets extra small, so as the x value gets closer and closer to 0 again, this number, the tan is going to get bigger and bigger. So my graph continues up until finally, again, I get that asymptote. And then as I keep plugging along, I come back up and I've got that repeated behavior. So notice here, one cycle is just over pi. Okay, so it's half the period of our sine and cosine. And if I was to just quickly go to the other side, so if I went all the way back around again, switch to the negative side, I'm going to get this as my graph. So putting on all of my asymptotes. So it's at the multiples, the integer multiples of pi on 2. So negative 3 pi on 2, pi on 2, negative pi on 2, 3 pi on 2, and so forth, 5 pi on 2. And it's going to keep repeating that behavior. So the full graph here, y equals tan of x. Oops, put that on the wrong one. There we go. So that red graph there, we've got, this is our tan graph. Okay, so it's got asymptotes at multiples of pi on 2, x-intercepts and points of inflections at multiples of pi, and the period is just pi. Okay, so that's our basic tan graph. Again, we're going to do some manipulations with it. Alright, so finally to summarize, here are a few of our key features. Okay, so we've got that the period is pi. Okay, so that's half of the distance it took for sine and cosine to do a full cycle. But that's how tangent works, the ratio of sine and cos. Because remember, these two guys, if I take the ratio of x and y, the points on the unit circle, that gave me tan. So taking the ratio of those two, they start repeating just over pi. It has x-intercepts and points of inflection at 2 pi and pi. Basically, it's all integer multiples of pi. Positive and negative. So we've got points of inflection and x-intercepts, 2 pi, pi, 0, pi, 2 pi, 3 pi, and just keep going. Whereas we've got asymptotes at the integer multiples of pi on 2. So we've got an asymptote here at negative 3 pi on 2, negative pi on 2, pi on 2, 3 pi on 2, 5 pi on 2, and so forth. Kind of a key point that helps to give shape. At pi on 4, we're at 1. Again, that's one of our special values. Pi on 4 is at 1, just to help give it a little bit of shape. And the axis where the graph is kind of centered about is the x-axis, which is the equation y equals 0. So that's our basic tangent graph.